Yeah, it wasn't great.
Why?
Because I got lost.
You got lost? You couldn't come up with the answer?
Nope.
All right.
I don't see how you got to 7.
All right. Okay, so what about the rest of us? How do we do?
Me and Eric got 2 different answers.
Two different answers?
We got 2 different answers.
It was hard, Rod.
But we don't know which one.
All right, that's fine.
I don't know which one's right.
That's fine. Let's go ahead and work on them. Okay. So let's start with the first one, right? First group, it was x minus 4 squared plus 2x, right?
Mm-hmm.
And it says that x equals 7.
Oh, it was 2x. I had a 3. Dang. Okay.
Oh, 3x. Yeah, you're right.
Oh, okay.
You're right with 3x. Okay. So actually, before that, let's just ignore and say, okay, we don't know what x is. Can we solve that equation?
Yeah.
No.
No.
We actually not. It's not even called an equation. There's another word for it. Do you guys remember what it is?
Nope.
This isn't an equation, but
Nope.
it's called an expression.
Oh,
Yeah.
Oh.
So this is an expression, and if we don't know what the variable is, then we can't solve this, right?
Mm-hmm.
So,
Yes.
well, not solve actually. So I'm using the wrong words here. This is an expression, and with expressions, we actually can only evaluate the expression, but we can only evaluate it if we know what the variable is. In this case, it's given to us that x is equal to 7. So what we're going to do is we're going to plug in 7 wherever we see an x. Right?
yeah.
And after that, we have to follow our order of operation. Okay? So what do we start off with first?
With my pencil.
Parentheses?
With the parentheses, right? Inside the parentheses, what do we have?
7 minus
7
4.
minus 4.
Which would be
3.
3.
3.
All right? Okay, so what do we do next?
The square.
The squared, the exponent, right?
Yes.
With our order of operations, we do squared, which is 3 squared is what?
9.
9.
All right, what's next?
Times 3 times 7.
3 times 7.
Right, because that's
7
separated
times-
by a parentheses. That's the same thing as saying multiplication. So 3 times 7, which gives us,
21.
21.
and now finally 9 plus 21
30.
is 30. So the answer right there is 30. So that's what it means to evaluate the expression, right?
Yeah.
Yeah.
I
We
was
got
so-
that down?
Yep.
Good.
Yes.
Okay. Next
I
one.
was thinking the answer was 7.
Oh, you were thinking the answer was 7?
Yeah, I was like, how the heck you get to that? I was like, no, it ain't working.
All right. So yeah, like first thing we need to decide is that we really can't solve it unless we know what it means. So let's see. This is the next one, which one was group 2?
Me and no.
Okay. So 2x plus 5 squared minus 3x. Is that what we got?
Yeah.
And
Yes.
x equals -1. So we're going to plug in -1 wherever we see an x.
2.
Okay. So how do we solve this?
2 times -1.
You
So,
start
yeah.
in parentheses.
Inside the parentheses, we
Parentheses,
start with
right.
that.
Yeah.
And remember that inside the parentheses, our order of operation starts again, right? So we first have to do the multiplication. So 2 times -1 would give us what?
-2.
-2.
-2.
Okay. What's next?
The parentheses, right?
It's still inside the parentheses. So
So
what?
3,
what's
right?
next?
-3, right?
-2 +
Not
5.
negative. It would be
Positive.
a +3. Yeah.
Positive 3, yeah.
-2 + 5?
Yeah. -2 + 5, which is +3.
+3. Yeah. Okay.
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 Yeah.
After that, what's next?
Mhm.
Exponent.
Exponent.
Square 3.
So 9.
So 3 squared, which is 9.
9.
And then what's after that?
-3
You
times
multiply
-1.
-3 times -1?
Right. So -3 times -1. And I'm glad, make sure you include the -3 times the -1, right?
Yeah.
So what does that
It
turn
would
to?
be +3.
+3.
Now 9 + 3, what's the final answer?
12.
12?
12. All right. So good job then. Okay. So last one, it is a little bit challenging. Oh my gosh. Okay, is that what we had?
Yeah.
Yeah.
So 3t minus 1 cubed plus 5t squared. And we had to evaluate it with t equals 0, right?
Yeah.
So we're gonna plug in 0 wherever we see t. Okay. So what do we start off with?
Parentheses.
Right, so inside the parentheses, what do we do first?
3 times 0.
3 times 0, okay? Which is equal to 0. Okay, so still inside the parentheses, if we do 0 minus 1, what do we have there?
-1.
-1 cubed. Good. Okay, so what's next?
The parentheses again.
So still in the parentheses, well, we're pretty much done there, so we can move on from the parentheses.
Oh.
So what's the next step?
Exponent.
The exponents, right? So
Yeah.
-1 cubed, what do we have there?
-1.
Will that be like -3?
Well,
Whoa.
actually it's -1, right? Because
Oh, yeah.
what does that
yeah.
mean? -1,
-1 times
sorry,
-1 times -1.
right. So -1 times -1 times -1. So -1 and -1, that's positive, but then positive times -1 would give us
-1.
-1. What about 0 squared?
0.
It'd be
It's
0,
still 0.
right?
Yes, it's still 0.
I see what I did wrong.
Okay. So then what's next after that?
0 times
-1 + 5.
Parentheses.
0 times 5.
Oh, yeah. Yeah.
We actually have to multiply. We have to multiply 5 times 0, right?
Yes. Which will
What
give you
happens?
0.
-1 plus 0. So
equals
-1 plus 0. What's that going to?
-1.
-1. Exactly.
Oh, I got 1.
You got +1?
Yes.
Okay. Elijah, where did you go wrong?
I didn't times the 5 to the 0, so it gave me 4.
Oh, okay, I see. So you added instead of multiplying first. Okay, yeah. Oh yeah, that one was a little bit tricky. All right, good job. But anyways, yeah. So that's the difference between. So I don't know. Let's just say we have 3x plus 1. Right? Remember that we call that an expression because we can't really solve it unless we know what x is, right? But let's say I add an equal sign. Now it changes. It's not an expression anymore. What do we call that?
Equation.
An equation, right? And can we solve an equation?
Yes.
Yes. Even if we don't know what x is, we can solve it for x. Okay, so that's a pretty big difference there. Okay, so my first question before anything, when we're solving equations, when we're solving for x, what is our goal? What are we trying to get to?
The value of x.
The value of x, but what does that mean? Like, I need to cancel things out, but at the end, what do I want to be left with?
On the answer.
So
You want x by itself? I don't know.
exactly. You're right, Eric. You want x completely by itself. You only want one x, right? Right now we have 3 x's. Okay, that's the same thing as saying x plus x plus x, right?
Mm-hmm.
So we want to have one single x, right? So that's our goal when we're trying to solve equations, okay? Okay. So okay. So when we're evaluating expressions, we use order of operation, right?
Right.
But when we solve equations, remember I said yesterday that we work backwards. So if we work backwards, what does that mean?
Like we would have to do 1 minus 1 minus 2, right?
Right, so let's just go ahead and go into an example and say, okay, let's say we have negative 11, and I'm going to use b as a variable, plus 7 equals 40. So if we were using order of operations, we would do we would do multiplication and division first and subtraction and adding and whatnot, right? But since we actually have to work backwards, what do we do first here?
We do
Minus 7
We
on
would
each side.
subtract. So we would subtract first. We'd subtract 7. So we do it on one side, and we have to do it on the other, right?
Yes.
So
yes.
negative 11 goes down, and 40 minus 7, what is that?
40 minus 7.
33.
33.
33. Okay. So now, and I say this all the time, right? What's almost always our last step?
Divide.
Divide. So what are we going to divide?
Negative 11.
11.
Negative 11 on both sides. So that cancels out. And then b is equal to 33 divided by negative 11.
3. Negative 3.
Negative 3.
Yes. Okay. So what we just did is that, we work backwards to solve this. So instead of using order of operation, we flip it on its side and say, we're going to work backwards. Okay. So let me see. So my last question is, I'm going to use that's z minus 3. Okay. So what would be our first step in this situation?
At 7 on both sides.
Well, actually before that, because if you notice, -7 is separated by parentheses. So what does that actually mean?
You distribute the 7.
Right, we distribute. We have to multiply that 7 into everything inside the parentheses first. Okay, so -7 times z, what does that give us?
Seven. -7. Same.
Negative 7
Right.
z.
-7z. Oh my gosh. And then -7 times -3, what is that?
21.
21, positive 21.
21.
Positive.
21.
Okay,
Positive,
Yes.
right.
Yes.
So now that we have that, we can start moving things around. Okay? And so what's our first step?
Subtraction.
Plus
Subtract
7
7 on
Yeah.
both sides.
minus 21.
We'd actually subtract 21 first, right? Subtract 21. And actually, here's where my question comes. Why, you've always heard, right? What you do to one side, we do to the other, right? So that's why we separate the equal sign. Like that's why we draw a line through the equal sign, right? Because those are the two sides of the equation. But why do we do that? Have you ever stopped to think and say, why do we have to do one side what we do to the other?
No, never thought about it.
Never thought about it?
Nope.
So
No.
we need to make sure that the equation stays balanced, right?
Right.
Because let's say we were to subtract 21 on one side, right?
Mhm.
If we don't do it to the other, if we don't do it to the other side, then that just means that we change the value, okay?
Yeah.
So let's just say, I don't know.
But then you have to do 47 times 7. No, 42. God dang it. 42 times 7. No. Never mind. I'm going to be quiet.
Sorry. Like, let's just say, it's just an example, right? Can we agree that 2 is equal to 1 plus 1, right?
Yes.
Yes.
So if I subtracted 1 from one side and I didn't do it to the other side,
The other side would be 2 still.
yeah, the other
And it
side would be
unbalanced.
2,
It'd be
and
unbalanced.
then one side would be 1. And you're right, it becomes unbalanced. I'm glad you used that phrase, right? So that
Yeah.
doesn't work, right?
Correct.
We would have to subtract 1 on both sides,
And you get 1 and 1, or 1 equals 1.
right? So now we haven't changed the value at all, so 1 should be equal to 1.
And they're balanced now.
Exactly. We're balanced. That's a really good phrase to use. So I'm glad to see, like, you never think about it when someone says you do to one side what we do to the other, but that's exactly what's happening, right? So we make sure that we cancel over here, but we're not changing the value of the equation. So
And then over there, 21.
42 minus 21 would be
21.
okay. So what is almost always our last step?
Divide.
Dividing.
Divide.
Division.
Divide both sides by 7. So z is equal to
-3.
-3.
-3. All right, pretty good. Okay. So let's see, let's do a couple more examples. Okay, so go ahead and try You guys go ahead and try this one. 13 equals 2m plus 5. Okay. So I'll give you guys a couple minutes. Go ahead and try that.
Did we tell you when we're done? When we're done?
Yeah, sure. Go ahead.
I got 4.
4.
Yeah.
Okay.
Me
What
too.
about everyone else? We'll just wait a little bit
Yeah.
on everyone else.
Yeah, he's right. 4.
You guys agree with that answer?
Yep.
Okay.
Yeah, 4.
4. Okay, so we subtract 5 on both sides, right?
Correct.
So 13 minus 5 would give us
8.
8.
8.
And then we're going to divide by 2. So n
Yeah.
is 4.
Yeah.
All right, good. Good job. Okay. Next, try. Let's try that one. All right, give me a second. I'll be right back. Did we get an answer?
Yes.
Yeah.
Well,
I
what
got
did we get?
13.
13?
That's what I got too.
Yeah.
Yes.
Did everyone
Me
get
too.
that? Okay.
Yeah.
So remember, what we want to do is we want to make sure that we simplify each side as much as we possibly can, right? So when we have parentheses, we want to make sure we distribute first. Okay? So 3 times n, that's 3n, and then 3 times -5 is
Negative 15.
-15. Okay, so from there, same steps, plus 15, plus 15. That's 24 plus 15 is 39. And then we divide both sides by 3. As I said, almost always our last step is to divide, right? And so what is different from these from two-step equations as opposed to one-step equations?
There's just more steps too.
Yeah, I mean, there's just really more steps to it, right? But in one-step equations, it was like, okay, I either add, subtract, multiply, or divide, depending on what the question is asking, right?
Yeah.
Now, in a two-step equation, we're gonna have some combination of adding, subtracting, as well as multiplying and dividing. So we use 2 of those operations in the same equation. I guess that's really the big difference. So as I say, your last step is almost always to divide, but let me show you an example where it's not, right? So we have j divided by -2 plus 7 equals -12. Okay?
Okay.
So in this example,
Like
I mean, it's still
division.
the same. We're gonna subtract 7 on both sides, right?
Yes.
So what's negative 12 divided by negative 7? Or sorry, negative
What?
12 minus 7.
Negative 19.
Negative 19, yes. Okay,
Oh yeah, you just add it. Okay.
right,
okay.
right. They're both negative, so it's like we're adding, okay? But anyways, now we have j divided by negative 2 is equal to negative 19. And obviously we should have practiced this yesterday in one-step equations. But what do we do to cancel out that negative 2 and leave j by itself?
Multiply by negative 2.
Division.
Actually, in this case, we're going to multiply.
Multiply, right?
We're
Oh.
going to multiply both sides. So since I always say our last step is almost always divide, in this case, it's actually not, right? In this case,
So
we actually
multiplication.
multiply.
So you just flip it.
Yeah. So if you
Flip
notice,
it.
that's just saying j divided by negative 2. So if we're working backwards, we're going to multiply by negative.
Okay.
So j is equal to
Times-
negative 19 times negative 2,
Positive 38.
positive 38. All right. All right.
Okay.
Good job, guys. So, okay.
Is that it, Ron?
Yeah, that should be it for today. Let's
Are
see.
you gonna post something else on Delta Math?
Well, your homework today is going to be on Google Slides. Okay. So I wanna make sure you guys show your work, so we can see that
Is
we
it
got
due
the
today?
process down. No, it's due on Friday. Okay. So make sure that you guys got the process down. So go ahead and do your work. Show your work. I think it's about 5 or 6 problems. So make sure you practice your two-step equations, and they're due on Friday. Okay.
And show your work. Right.
Yes.
All right. Later, Ron.
Sure to show your work to get your full credit. Okay. So I'll see you guys tomorrow at the same time. All right.
All right. Later.
All right. See ya.